Prove that cos 2x is equal to cos square x minus sin square x, 2 cos square x minus 1, 1 minus 2 sin square x, and also 1 minus tan square x by 1 plus tan square x, where x is not equal to n pi plus pi by 2, where n is an integer. So first thing first, let's start with the first one, cos 2x. So what identity which we already derived can we use to do this question? Search for it. What can we use? So we have derived pretty much from here till here. Yes, we can make use of cos of x plus y. That is, I can rewrite this as cos of x plus x. And now I'm going to state, because cos of a plus b is equal to cos a, cos b minus sin a, sin b. What can we infer from this? A is equal to x, while b is also equal to x. Now, what do we have? This is cos of a into cos of x, actually, into cos x minus sin x into sin x. And what is this? Cos square x minus sin square x. That's it. As simple as that. Now, how do I derive the second and the third one? That's also quite simple, actually. We know that one can be written as sin square x plus cos square x. Agree? Now from this, what can I tell? I can tell that, let me rewrite in this manner, 1 minus sin square x is equal to cos square x, and also 1 minus cos square x is equal to sin square x. So as when I substitute over here, things will turn out to be that cos 2x is equal to this and this. So let me call this as first and second. Let's substitute that in a. Let's substitute the first in a. What do we end up with? Cos square a. In place of that, I'm going to substitute 1 minus sin square a. So we have cos 2x is equal to 1 minus sin square x minus sin square x. So this is 1 minus 2 sin square x. Agree? And then we have, let's substitute the second in a. So we have cos of 2x is equal to cos square x minus, in place of sin square x, we are writing 1 minus cos square x. And so we have cos square x minus 1 plus cos square x. And so this is equal to, this is 1 cos square x, 1 cos square x, this is 2 cos square x minus 1. And thus we have the following set of expressions. Agree? And last we have 1 minus tan square x divided by 1 plus tan square x. How will we derive that? So the last one would be cos 2x is also 2 cos square x minus 1. So can we use this? Think about it. What can we do? What is the relationship between cos and tan? How can we establish a relationship? Think about it. It's not too hard. Your clue is secant square x is 1 plus tan square x. That's your first clue. Next clue is cos square x is equal to 1 by secant square x, right? And so we have this entire expression is equal to 1 by 1 plus tan square x. And when I substitute it over here, cos 2x is equal to 2 times of 1 plus tan square x minus 1, and as and when we take the LCM, we end up with 2 minus of 1 minus tan square x. Remember, this is in brackets. When I open the brackets, we'll get that. So 1 plus tan square x. So minus of this entire expression is 2 minus 1 is 1. So this would be 1 minus tan square x divided by 1 plus tan square x. And we have the following answer. That's it. Right? So everything can be derived from everything else. Just a matter of learning it sequentially.